you declare that you're not good at answering those questions. So the thing is that usually the case is that your concepts are not strong in the first place. So you're unsure about the concept. If you're unsure about the concept, then how are you going to write a proper answer? That's not possible. Yeah. Where do I start? Do I start with your do I start with your questions? You had some questions, right? Which I ghosted you on, right? Huh? I ghosted you a bit. No, I just really couldn't find the time to settle all this because my year fives graduated this like last week. Like the final few lessons were like last week and this week. Yeah, I know. So why you do you know that when are your results coming out for promos? Do you know when they're going to release your results? No idea. There's a chance that they're only going to return your papers in December. Really? Last year they got their papers back like damn freaking late. Like all of them. Like I couldn't do anything. I couldn't do any paper review or anything like that for them. Yeah. Very strange way of dealing with things. Amanda. Okay. So what's the question you want to ask? Oh, the graph one you sent me already. So you went for your practical already. No issues, right? And then you sent me some weird ass question. What's this? Oh, you send it into the group chat. This one? Okay. Okay. What's the minimum distance between the two cars within the first 12 seconds? Right? Okay. Hang on, This shouldn't stump you, leh. Like, I'm looking at it, I already kind of like, I know I've gone through this before, leh. Minimum speed? It's not about minimum speed. Minimum distance, yeah, correct. No. Shh. Okay, so you see, right? Okay. So in the first 5 seconds, right? You see the first 5 seconds, right? Okay, do you see this area here? Right, what does it tell you? Wait, this says car Y is ahead, 450 meters ahead of car X at time equals to 0. Right, at time equals to 0, car Y was actually ahead. Correct? Okay. Then what happens is that, but then the thing is this, right? But then the thing is this. So from 0 to 5 seconds, car X is covering this much distance, right, compared to car Y. Correct? So what's the area of this thing here first? Do you find the area? Okay, let's say this area here, I call it A, okay? I don't care, I just call it A, okay? Alright, then I call it A. Right. So at this point, right? At this point, 5 second mark, not 12 second yet, okay? 5 second mark. Has car X overtaken? Is A more than 450 meters? That's the big question. Right? If it's more than 450 meters, okay? Then, if it's more than 450 meters, then car X have overtaken car Y. If it's less than, then car Y is still in front of car X. Come, sit down. Yeah. Then car Y is still in front of car X. Yeah. So how much the area first? We need to find out. Because only when we find out what's this area, right? Then we can tell how close they were at some point. Not yet. Yeah. How close are they lah? What was the closest they were to each other? Yeah, but the thing is that it's not so easy, you know. Because you need to see whether X has overtaken. What's that? 150 only, 150. So what happens is car X has close up the gap to how much? 450, then car X travels by 150 more. 300, right? So right now, at this 5-second mark, car Y is ahead by 300 meters, correct? Then immediately what happens after 5-second mark? After the 5-second mark, what happens? Car Y is now faster than car X. Which means the closest they ever got to was 300 meters. Yeah, how come the answer key don't explain things like that one? I don't understand one, no. No, I don't get it one. Like, why do they show these kind of things, right? Instead of like showing pictures like this. Like, it takes the same amount of effort to create answer key, right? Why don't you just screenshot this thing, right? do this one here, and then say tell the student instructions, right? Find area A. Area A is the distance that X closes up on. You know, why can't they do that? I don't get it, you know. Every time I answer your questions, right, guys, I always do this one. Why can't they do that? You understand, right? When you see my working, you see some of the mark schemes, so I don't understand one. Like you see okay, you see 这个是什么 What's this? I don't get it. Anyway, now there could be a case whereby, Amanda, there could be a case whereby this area here, right? Let's say this area here is 500. Right? Okay, you imagine 500. So X is now ahead, right? Okay, but then Y will then overtake, right? Correct or not? So then the closest distance will be 0. Because you go past, right? You go past the closest distance 0 ma. They never put 0, stupid one. Put 0 lah, then people will think, I think 0, because they can overtake, you know. Right or not? Yeah, these people don't know ni. I don't know. I need to settle your question from the WhatsApp. From our group chat. Oh, okay. So it's part of this paper, is it? What paper am I going through? NY 2023. So the RI girl, the Cassandra, she had her exam. I haven't gotten her her feedback yet, but the review I did with her, like, can tell that forces was not a thing for her, like the forces and all that, like where the force is pointing and all. Wait, why you send me another one there? Wait, is this from the paper? This EJ paper, okay, can. I almost gonna open the NY paper, but okay. Crop and then make brighter. Ayo. It's okay. Okay, right? Rubber ball dropped from 2 meters, undergoes elastic collision with the floor, no air resistance. What's the distance S above the floor for bouncing ball the instant that it is dropped? Isn't it B? Then why is your answer D? No, wait. Oh. The green one's B, yeah. Wait, why? Okay, objects bouncing, right? The displacement time graph is the motion of the ball itself. Wait, what? No, what I was concerned with, it could be D. It could be D. You know why? B and D are correct if you take the original position as a different position. So for B, right, B is correct because we are taking the floor as zero displacement. When the ball reaches the ground, we take it as zero displacement, then it bounces. Right or not? Then for D, we take no, D is wrong. Sorry. D will be wrong. D is wrong. But then the other version will be something like this. Something like that. The other version might be like this. Or like that. An option like this would have been correct. Yeah. Because you take the original position as 0, then as it's falling down, you take it as positive. So as the ball falls down, it has positive displacement like that. Hits the ground, and then it bounces like that. So this could be an option as well. This could be an answer as well. Yeah, it's weird, right? Yeah. No, so you're taking downwards as positive. You take the initial position of the ball as 0, then when you drop it, you take going down as positive. So then it'll be this curve. It'll be damn annoying. Okay? So the displacement time graph is the motion of the ball itself. Can I ask you to draw the velocity time graph? Like if I ask you to draw the velocity time graph, how would it look like? Zig, then zag. Correct? Okay, then if I ask you to draw the acceleration time graph, how do it look like? Constant, bounce, constant, bounce. Right, so that's how the acceleration time graph look like. We okay? Yeah? Okay. Yes. Yes, yes, yes. Okay, back to the paper. What? Oh. What's so demoralizing? Promos, NYJC package. Package 1, is it? Then 2023, paper 1, is it? Oh. Paper 1, I sort of done already. No, wait. Amanda's question on the group. I ask you, time limit on those, right? Oh my gosh. Sorry. What? Oh, this is a MI paper already. Okay. Okay. Yeah. I go through. Which one? Oh my gosh. Oh. 5. 5. 5. 5. Okay. Oh gosh. Why can't you do 5? You started with me with projectile motion, eh? Walao. How come you don't know how to do this? I am legit worried. What? You couldn't draw? You couldn't draw a hot air balloon? Go and take art classes lah, walao. Cannot draw. Wait ah. Oh my gosh, sorry. I sneezed and then I think I pulled a muscle. Alright. Hang on. So constant speed of 4 meters per second at an angle of like hot air balloon. So the hot air balloon is like that. The hot air balloon is doing something like that. Meta. Like that. Then it's like woo, right? 70 degrees to the horizontal, right? 4 meters, 4 meters per second, right? The wind blow lah, like that. You know what I'm saying? And so when you drop something, right? You drop a ball, the ball will have the woo feeling also, right? And the initial speed of the ball will be 4, and the angle to the horizontal will be 70 degrees. Why? Correct or not? Then right, you know what you do? You just erase the hot air balloon. Don't carry. You just focus on the ball. Now you tell me you cannot do projectile motion for this? Huh? You tell me. Huh? You tell me. Huh? Like that, oi. You tell me you cannot. Cliff, right? You kick a ball at an angle. So you see, right? The trick for projectile motion, the trick for projectile motion is whatever scenario they paint you, right, does not matter at all. Because at the end of the day, you're always dealing with something like that. Cannot. Hey, hello, tomorrow exam eh. Jialat. Stress. 6. Then 7. Alright, 6 Oh, sorry. Question 6 Oi. Hey. Oh, between Q and just before landing at R, is it? Okay. Something like that, Okay, so Q is here, right? Okay, I teach you. I tell you something. Okay, this change velocity is quite recent. Change velocity for projectile motion. Whoa. Rain. Rain harder. You asking for it. You asking for it. See who he listens to. You know, no, maybe he listened to both. Right now rain like mad. Then afterwards you dry up already, you can go home. No. Okay. You won't be trapped here with me, don't worry. I also don't want you here. Okay. So this question in recent years I noticed gaining popularity. Or maybe, like there's this question that goes around being recycled, right? Yeah? Okay, so the concept is this. Break it into components again. Okay, break it into components again. Right or not? Okay, if you break it into components, if you remember projectile motion, which component does not change? Correct. Horizontal doesn't change. So which component changes? So when they ask you for change of velocity for projectile motion, you're only just looking at the vertical change only. In fact, whatever the answer is, right? Whatever the answer is, the change, right, is in the vertical direction and it's pointing downwards. What's causing the change? What's causing the velocity to change? Specifically what acceleration here? Yeah, gravitation acceleration pointing vertically downwards. So the change is always going to be downwards, right? It's going to make this vertical here right? Change to 0, and then afterwards it's going to make that 0 change to downwards vertical of the same amount, which just means that all you have to do to find this answer is just to find out how much is the vertical component here. So V sine 36. And that's your answer. Don't nod your head. Help me find the answer first. Find the answer. What's that? 0.59, so that's the answer lah, right? Okay, hang on. Okay, so the change from start to middle is 0.59 V, right? Okay, I'm gonna ask you this, okay? How about from P to R? What's the change total? What's the total change from P going to R? How much? What's that? What's it? 2 times what? 2 times 0.59, got it, correct. Okay? 2 times 0.59 V. Because when it lands, it has V sine 36 degrees but pointing downwards. So the total change from P to R is 2 times 0.59 V. And which direction? Downwards. Yeah. Yeah, I have not really seen this question appear before. But the thing is this, the first time I encountered this was actually in the IB paper. So maybe one of the teachers got inspiration from there until they say, oh, it's an interesting question, and then they start putting it in here. That sort of thing. You never know one. Okay, what's the next one? Huh? 7? 7. Okay. Okay, key phrase here, key phrase here is constant force. Sometimes we get this kind of question, right, where they tell you that the engine is constant power. But in this particular case, it's constant force. We just take what the question is saying. Okay? So the question says constant force. So we take it as constant force. So that means the power might not be constant, no? Because P... Wait, this is momentum, sorry. Okay, so it's not power, sorry. I thought they were talking about power. Okay, momentum, Momentum and distance, is it? Momentum, isn't that just MV and displacement? MV and displacement, constant force, no resistive forces. Isn't the acceleration constant? So of all the relationships between the Suvet equations, because A constant, that means you can use Suvet, right? What is the relationship between V? Because I can ignore M for a while. What's the relationship between V and S? And then you start from rest. V squared equals to 2AS. That means V squared is proportional to S. And since you're plotting Y against X, right? You're plotting V against S. It's like you're plotting Y squared is equal to MX graph. Which by curve sketching, which graph is it? D. D the answer? D is the answer. Cannot. I think I need another coffee. Okay, come, let's go on next one. Question 10. Why, question 10 not easy, Question 10 not easy. But I will kick you. Okay. What's the total force stored in the spring? So if you use one spring, it hangs down at the equilibrium position, correct? Then his question is, what happens when you use 2 springs, is it? Total force, I don't understand the total force part. Like each spring is F over 2, right? Yeah, each spring is F over 2. Correct or not? I think so, lor. I don't know. So the thing is, it's a bit tricky. So I have to look at the total energy. It's like you might as well don't ask me for force. Because you ask me so vague. Total force in the springs. So if one of them is half F, the other one half F, so do I sum it up? Total force is total F? Or do I say that, like, total force in one spring is half F? I don't know, right? So it's like I have to contend between these two options here, which also means that at the end of the day, I might have to check the EPE, right? That's all I can do, right? Like you might as well don't ask me about force, boliao, just ask me how much EPE lah. Right or not? Because your question vague, I cannot help, right? Your communication skills are zero, right? How I cannot help, right? Right? You need to go take speech and drama or something like that. I don't know. Don't you think that some of the teachers need to? Yeah. Oh shit! I laughed too loud. Yeah. Okay. Never mind. Every school is a good school. Every teacher is a good teacher. Okay. So you got to remember my lesson lah. 2 springs means what? What's the K effective? Yo. So it's just 2K, right? Okay, 2K. But what about the energy stored? It'll be what? Half K effective X squared, right? X squared, right? But the problem is, when you extend this one with one spring, if let's say the extension is X, then what's the extension when it's 2 springs? It's only half X only. Yeah, correct. It's only half X only. So you know what? Half K effective, right? Half X squared, like that. Okay. So this turns out to be half 2K, 1/4 X squared, and this one is half KX squared. Correct? So basically it's half lah. So the only answer is B, oh? Right? Stupid question for the force part lah. But this one, yeah, correct. Correct lah. I know. You got confused with the force. If you realize that you're not sure, right? And then you look, you have strategy. MCQ strategy is not just 死板板 get the answer, no? Huh? No, it's not about which one comes out more lah. Don't use some stupid method. I say strategy, not stupid method. Right, strategy. So you see, right? Basically, you might as well don't ask me about force because I'm not sure, right? Correct or not? But it's right lah. If you down there you think one spring is half over F over 2, then you go and choose A, then you get it wrong lah. Because you'll be thinking like, oh, I know it's F over 2 ma, right? I don't need to check the energy anymore. Jialat. Actually, you need to check an energy. Okay, number 10 done. Next one. Twelve. All right. Wow. This one not easy. Oh, this one I also just went through Cassandra also. Just one of her papers also. Okay. All right. The cable. All right. So there's one cable pointing here. Sorry, the one of the forces pointing this way. Right. One of the forces pointing this way. Another force pointing this way. Right. Okay. So these two forces are pulling the pulley towards D. You understand this? And in fact, there's two forces. So, whoa. So you see this pulley here? Okay. So these two cables are actually two forces. So one side pull here, one side pull there. Both of them, if let's say I ask you to find the resultant of these two, right? You legit have to draw one vector here, one vector there. Don't think that just because it's one string, right? How come one force pull this way, one force pull this way? How come it's not like one force pull this way, one force pull that way? It doesn't make sense. What you can do is this: you can take a string, right? Take a hair lah, right? And then you can put something there, right? Like a eraser there, and then you pull both sides. You realize that both forces are acting on it. So the resultant force is actually one side and one side. It's the same magnitude, different angle. Hang on, but that's not an answer. So the two forces acts on the pulley, acts on the pulley, right? In the direction of D. Correct or not? In the direction of D. But this question is asking you what's the direction of force that force on the pivot of the pulley. On the pivot of the pulley. Not by the pivot. On the pivot. And then D. Yeah lor. So it's answer D? Answer D, right? Yeah, correct. So you imagine you imagine you are the pivot lah. Okay, okay. This is the pivot, right? The pivot is this stick here. The pulley is this wheel that goes around like that. You know what I'm saying? Then you have like a string that's wrapped around the thing like that, and basically like there's two sides pulling down on the pulley. So the pulley pulls down on the pivot. Okay. I thought they were asking by the pivot. If it's by the pivot on the pulley, then the answer is B. This one is not easy. This one. But actually, it can be quite easy on it. Just think about what's acting on what. That's the most important thing. Yes, that's right. So the pivot is kind of like reacting back on the pulley, right? Yeah. So cable pull pulley crushes pivot react back on pulley. So B is like the reaction force by pivot on pulley. Wow. I think got lightning show eh. Where over there. Is he gonna come over? Okay, come. What's the next one? Seventeen first. Okay. Block is attached to elastic spring of unstretched length A. Did I go through this with Jiaxuan? Wasn't there a... No? Or maybe I did it with the J2s. So you have a elastic spring of unstretched length A travels in a horizontal circle at radius 2A. So previously it was just A, but then it was being stretched to 2A, correct? Then there's a mass, is it? Is there a mass? A block, right? The block. Okay? And it's going around in a circle like that. Okay? Radius is 2A. Okay, period is T. Spun with a higher speed, so the radius is now 3A. What's the period of rotation? Damn. Okay, so first scenario, right? What is the relationship for the circular motion of this block? Yeah. What? F elastic spring is equals to Fc, correct? So F elastic spring force is Ka, but not 2A. Why not 2A? Why just Ka? Because it was A at first and it got stretched to 2A, so the extension is only A. Fc, which equation would you use? mr omega square or mv square over r? Mr omega square. M 2A. Omega is 2 pi over T whole thing squared. Okay, that's for the first scenario. So the next scenario is going much faster now. So what is the equation for the second scenario? K 2A equals to M 3A 2 pi over T2 squared, right? Because we're trying to find the second period. Okay? Do what you need to do. The rest is math already. Not my problem. You have to do that fast. You have to be very fast. You have to be very, very fast. You want to do it now? Yeah, you do it because I say that you have to be fast. Wait, I'm very hungry. Wait. We good? <clears throat> 18 ah? 18? Wait, what method are you using? You have to use energy. No choice. So you got MGH here, convert to K at the bottom. K at the bottom go up, minus away Mg2R. Then that's the K at the top. That's it all. You know? Just use equation, find V. They want V, right? Oh, centripetal force. So then you use equation, find V and then mv squared over R. Yeah. Faster must be faster. Cannot be so slow. This one is can save time because you know how to do it already. So you have to do this within 45 seconds. Let's go. Hey, faster. The TikTok reel repeat twice already. Oh no, session stuck. MGH minus mg2r equals to half mv squared at the top. Right or not? GH minus 2gr equals to half vt squared. Already vt already, don't have to go in square root. Right? So mv squared over r is equals to that thing lah. Right? Looks like D is the answer, is it? Yeah, D is the answer. Yeehaw! No, Chelsea, you went down the wrong rabbit hole. I know she's trying, she's trying. !aiyo! 不要教他了啦，你这样 got internal injury, just let him go already lah. Why you care? Right or not? This one really deserve it on this one. This one the 头脑 is not working properly on. That last year right got some project, you know. Ask her how to design a physics project. She taking combined science. How to design a physics project. Then he said he got idea. He want to see like the bounciness of the shoe, right? So I was thinking, then I suggest to him, okay, can bounciness on the shoe sounds like a good idea. You take a tube like this, you put it into the sole of your shoe, you take a golf ball, you drop it, and see how high it bounces. That would be like the correct, right? You know what he said? No. I think I'll do it my way. I will just wear the shoe and see how high I can jump.
But you can't control your shoes.
Yeah, you see, that's the immediate thing, right? That's why you're a physics student, and that's why the guy is being scolded like that. See. That one is called tu. You know what I mean? So the worst part about it is like, I already suggest to you already, right? You still insist that you want to do your way. Correct, right? Then okay lah, never mind lah. You just go and do whatever you want to do lah. It's fine. I mean, you see, right? To a lot of things in life, right? Ideas and suggestions come very easy on, but to execute is really you have to go and do it properly. I already give you idea already. Your job is just to execute. Oi, 快点. On the way already. Hey, hang on. There's a chance, right? Lightning strike, this building will black out on. Just give you forewarning first lah. Yeah. It's a thing. Yeah, it's a thing. Yeah. No. Yeah, but yeah, like couple of times each year lah. Yeah, not each year lah. Like once a year. But I think for the past 1 year, touch wood. Yeah. Maybe they fix something. I don't know. What? 26 and 20. Oh, 26 this one? Smooth piston. Expands under constant pressure. And therefore, what's the heat supplied to the gas? Internal energy given. Volume given. Pressure also given. What's the heat supplied to the gas? Del U equals to Q plus W. Del U is 3/2 PV minus 3/2 PV. 有没有看过? You're right. Q is unknown, is the thing that we're trying to find. And then expansion, right? Minus P times 0.5 V. Which part wrong? No, I think it's because of the del U. Eh? Oh, no, hang on. But the final answer is still left in must have U inside it. It's either got U inside or no U inside. Correct, right? Like this option here, there's no U in it. So, I don't know also. Oh shit, there's a chance, right? Okay, let's try without the U first. Okay, hang on. So 1.5 minus 1, so 0.5 V, right? Isn't it PV over 2? Equals to Q minus PV over 2. Yeah, so cannot be A. Because the heat supply is actually P times V. right? But then they didn't allow us to have any option of P times V. So now we have to do it in terms of U. So we cannot use this method. Sorry. Yeah, this method cannot use. So del U is what? What's the change in del U then? So one is U, then since the volume increased 1.5 times, then the new U is 1.5 U. Right? Because internal energy is 3 over 2 PV. That's U, right? U is equal to 3 over 2 PV. Then if you increase, if the volume is 1.5 times the original volume, then the internal energy is 1.5 U. So it becomes 0.5 U. So U over 2 is equal to Q minus PV over 2. Correct? So therefore D is your answer. Annoying leh. Because you have to check whether or not A is correct. Yeah. Okay lah, but if you didn't, then you would have gotten D anyway. Okay, 26 done. Next one. Well, all these, hey, they like to use a lot of like letters and variables. No real numbers, huh? It's their thing, Okay. Anything else? What's the next one? What's the actual definition of displacement? So it's a straight line length, right? Because length is a base unit, right? Base unit, that means length is okay. So you can say is the length of the line that connects the initial to the final position of an object. Yeah. Why? What does the answer key say? You can say initial to final position. Oh, with a direction. Yeah. Yeah. So it's quite annoying. But actually, I tell you, over these years, right, like more and more schools have their own versions of their definitions, and it's quite annoying. So while this is Churchland's definition, maybe yours is different. Yeah. It must be the shortest straight line distance, right? Shortest straight line distance between the initial to final position, pointing towards the final position. Like since they ask for displacement, you have direction, right? Yeah, pointing towards. Which one? 3D. 3 donkey. Okay. Okay. So you look at this picture. I know this because I've done this many times before. The two strings, right? The tension is different. Confirm will be different. You know why? Because one, right, acts this way, right? The other one acts this way. Then you got the weight of the ball, the box also. So one of the strings will be more tight. Will have a bigger tension, which is the top string lah. The top string will have a bigger tension, right? So in fact, right, if you were to break up the components, right? So you got your horizontal component, vertical component, horizontal component, vertical component, right? The top string's vertical component, right, must balance the two vertical components. Yeah. Then the two horizontal components towards the center, that's the centripetal force for the 4 kg mass. Okay, sorry, what's your question actually? Part D. The rotation is gradually slowed down until the lower chord loses its tautness. Determine the frequency of the mass of the rotation of the mass when this happens. Hey, hello, Xue. If the bottom string loses its tautness, then you don't care about the bottom string lah. Only the top string is lah. Then it's just your normal like that. This kind of circular motion. Oi, hello. But this kind of thing also I need to spell out to you. Oi. Yeah lah. The bottom string loses its tautness. Not tight means no tension. You want them to really spell out to you, is it? You want them to tell you exactly that when it loses tautness, it means that the tension in the bottom string is 0. Hey, you know there are two types of people in the world or not? No, no, no. One, right? The first kind of people is that those people who can infer, right? Infer things, right, in the absence of direct, instruction. Okay? Hey, don't ask about number 2. Okay. Previous question. Wait. Oh. Yeah lah. Which means that the CG of this block is closer to the left side. No. The CG of the block is closer to the right side. Right side. No, that one is if you're standing on a platform. Let's say you are standing on a platform, right? Then the two pivots here like this, right? Then if you're standing closer to the one on the left, then the force on the left side is stronger, right? Correct or not? But here the thing is this. This thing, right, is the CG of this block, the weight is acting downwards like this. You understand what I'm saying? Then there's an upthrust acting on it. Now, upthrust should just be acting straight up in the middle, right? That should be the upthrust. The tension in cable X and Y are actually pointing down. Like the cables are holding it down, right? Okay, by doing so, right? But you can use moments, I mean, we can use moments, but you have to think about it and confirm first. If let's say you take the pivot here, right? Then cable Y force times this distance must balance mg times that distance. Huh? What? Oh, no, not balance. Sorry. Uh, Wait. If I were to put pivot here, these moments and these moments must be trying to balance the moments of the upthrust, right? But because this is so close to that pivot, right? Then this guy has to compensate. So the force by this guy is larger. You get what I'm saying? Right? But I don't know how to put it in words. Like I know, right? But that's always the problem, right? Because now they change the scenario and therefore I cannot. So I said, I mean, deduce why. Then I think the answer for 1 mark though, it's just 1 mark. That means what? The center of gravity is closer to y. Okay lah. But if you had to explain, then you just say that compare taking moments at x and y. Right? If let's say they ask you to explain, I give you the explanation here. Compare taking moments at x and y. This is only if they ask you to explain. Sorry. Something like that lah. I mean, just very roughly lah. Right? Yeah. So the language needs to be refined. Can do? Part F ah. Wow. Part F all the way. Determine the increase in length of each cable when an initially empty roadway becomes fully laden. Oh my god, what? Skip. Hey, but then each cable also. They say determine the tension. Is it the same? All the cables will have the same tension? How come? Okay, so you went all the way to E already, is it? Tension in each cable supporting section A. Yeah, better than the bio people lah. Yeah. Oh, is it? I thought usually bio you just leave it to the last day or something. Pair of cables on both sides of road. I have no freaking idea what that means. Oh, yes. Just leave it on the table there, can? Just ask him leave it on the table. Oh, sign. Oh, yeah, you help me sign. Help me sign. Huh? It's suspended. This section is suspended. It's just a hanging piece. Like that. Wait, So there's a force this way. There's a weight this way. There's a tension this way. Is there? Because it's being pushed like that, right? Because there's a block. There's another block that has there's another cable, right? Hmm. Yeah. Oh, is there traffic now? Oh, it's fully laden, is it? Yeah, why not? You just put the normal force, ah. Then you tell them that why are there no. Then you ask them more. I mean, you're right. I will argue with them. Then the answer, then they will tell you something, some BS. Say, oh, answer key say don't have, so we don't have. BS one sometimes. By the traffic on the section. Yeah. But I don't understand this one. What's this pair of cables on both sides of the road? That means got two lanes. If you look at the top view, got two lanes. So this is one lane, then another lane. Then there are two cables on this side and on this side like that. So but when you look at it completely side view, these two cables are like one behind the other one. That's why I said two cables, huh? What's the tension in each cable? You got this right? Then you got the force constant, right? Which means you can calculate the extension of each cable, right? No, you know the thing is this, right? So there's one cable like that. So there's tension on this side. There's tension on this side. It's pulling this way and pulling this way. So the two sections are pulling it downwards like this. So you find the increase in length of one cable, then you multiply by 2. I believe that's the total increase in length. Huh? Isn't one cable just a continuous cable? Then each cable forms an inverted V shape, right? So it's like it goes over here like this, right? Right or not? So if you I don't know. The answer is probably some convoluted way of calculating this thing. What does the answer key say? How many points do they how many cables do they use? Do they use 20 cables or 10 cables? Huh? What? They only just use one? So do they multiply the extension by 2? No? Sorry, this kind of things, this kind of questions is one of those like where they have the idea, but then they're just very bad at conveying the idea to the students. So even I have no freaking idea what they're asking for. Yeah, like I know like you just want the extension, right? But then who knows what you really want, right? Was this 2023? Is it? Question what? Yeah, I don't see it though. Sorry. What? Oh, it's paper 3. This one is it? No, I really don't think they please they don't even know what's going on also lah. Huh? Sorry, I have no freaking idea what's going on. I'm sorry. Like what's this 1.387? What did they do all this for? The increase in tension from 8.5 to 12.5. So the previous answer is this amount of tension in each cable. So this is when it's fully loaded, is it? This tension is when it's fully loaded, is it? Okay lah, yeah, fraction lah. So basically the tension, right, is the lesser load divided by the full load, then times this lah. So you're doing fraction, right? Okay. Yeah. I think the thing that I'm confused myself about is like, let's say you have a cable, right, and then you extend a tension, let's say like this, right, then it extends by maybe a certain amount like that, correct? This is the extension, okay, right? Versus what happens when you loop this same string, you loop it around a thing, but then you connect it to the same mass like that. Then extension is what? It's half, right? Isn't it? Right? It only extend by half, right? So that's my concern, right? Because this question here is like, you have that V-shaped thing. Isn't this thing looped over like that? Then it's supporting the same weight like this. So do we like, if you ask us for the length extended by, no, okay lah, as in, so from part E already you have this, right? Then it's just basically, yeah, it's just F equals to kx, and then they just want you to find x, then F over k, that's it. That's all. I mean, like there's nothing to like confuse about lah. It's just like very long-winded. Okay. Do I need to bother anything about this? No? Okay. Paper 3? So paper 1, 2, 3 tomorrow. Okay. Paper 3, anything? No. Oh, is it? No idea. I have no experience with what kind of teachers NYJCs are like. Yeah. I just know that they go very fast, that's all. Yeah. But yeah, it's a problem. If they didn't use the word SI unit but they use the word suitable unit, then that will make sense. Suitable unit is makes sense for km per km square. You understand? SI unit must be meter, right? Yeah. Anyway, next one. You take this area, you divide it by the mass of Q. That's it. Yeah, why? But why? At first, and this is the force that Q experiences, right? So what does the force under this area give? What does the area under this graph give? It gives you impulse, right? Which is what? The change in momentum, right? So you take this area divided by the mass, that will be the final velocity of Q. Right? Okay, next one. So A and B, the difference is 0.1 second, right? Then what's the difference in distance between A and B? Like B is a later thing, right? It's traveling towards the right, right? Like how far is B away from A? Like based on distance. The wave shifts, ma. Yeah. So how far is B away from A? 0.04. Okay. So 0.04 divided by 0.1. Yeah, distance over time. Yeah, distance over time. Next one. So all quite easy, this one. Huh? Planning the are you tested on planning? No, right? Okay. Number 5? Need or not? Oh, you haven't do yet. Oh, then you wanna ask other questions? Do you have a section B where you have to choose one question? Or you do all? Okay. Weird, 2 years only, so different, the promos. Because the Earth is very big and the surface is approximately flat and the G field lines are approximately parallel and equally spaced. Hence, for a short distance above the surface of the Earth, the G field is approximately uniform. But only for a short distance. Huh? What? Which one? This one? Oh, because you need to talk about acceleration free fall. I thought you asked me why is it uniform lah. Yeah, so yeah lah. No. Then that talking about it being constant is one thing. Then you talk about something else. You must now say that for objects falling, right? They experience gravitational force right, by the Earth, in the absence of air resistance, the gravitational force is the resultant force. mg equals to ma, a equals to g. Hence, g field strength is numerically equal to the acceleration of free fall. Yeah. Yeah lah, a lot to write for 2 parts. Then you have to say that. Then remember what I said? So the important. So the astronaut in the space station are orbiting around Earth. They have the same centripetal acceleration. They have the same gravitational acceleration. They have the same circular motion, right? And hence the astronaut does not come into contact with the space station. Without, in the absence of air contact force, the astronaut experiences apparent weightlessness. Yeah, that should be the answer, right? Does answer key say that?
They said both spacecraft and astronaut
Yeah, 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 yeah.
whole system provides acceleration and
Don't need to explain that lah. We are already saying that the centripetal acceleration is the same already. Right? Why need to explain that part? Bo liao. It is your G field strength, yes, it is. But it's not 9.1 lah. There you see? So there's no apparent weight, there's no normal contact force. Yeah. May I answer Shoshan's question? Where is that from? There's no driving force. There's no driving force. Oh, Shoshan, there is no forward force. You draw like that, right? You get it wrong already. So always remember that when you hit the golf ball, right? When you hit the golf ball, okay? Right, golf ball, golf stick. Right? So when you hit it, right, you just tap it, then it moves. Correct or not? But the moment it comes out, right, the moment it leaves, no more forward force already. So when we tap it, right, that means we give it the initial speed. Pop, like that, right? Okay, wait, pop, like that, right? Then the rest of it is just friction. Right? Friction causing it to slow down. Understand? So what they're saying is that for the same friction, right? So you have a golf ball, you have like this, right? So this is the first speed, right? With a certain amount of friction, it travels s, for example. Okay, right? I will say this is u1 not v1, u1. Okay, right? So s is equals to well, actually I should use v squared equals u squared. Okay, right? So v squared equals to u1 squared plus 2as. Alright, 0 equals to u1 squared plus 2. Now acceleration is friction equals to mass times acceleration. Acceleration is the deceleration. So F over m. Correct? Right, so I'll put F over m. Right, F over m, but I'll change the sign to a minus sign. Times S. Right. Okay, then what's the objective of the next one? The next one is still again 0, right? But this will be u2 and u2 squared minus 2, right? F over m is still the same, right? Friction still the same, mass still the same, right? But it has to travel 3s now. So find u2. Wow, again, variable question. No numbers on. Okay. Okay, I got another class coming in soon. Quick, last ones. Anything else? 8 Part B. A part B. So you consider equilibrium first before you do X. Equilibrium is what? Equals to weight, Okay. Rho is what? Rho is density of what? Of the liquid, right? Okay. So can we say that at equilibrium, right? At equilibrium, mg equals to, I'm going to use this as h. This is the height of equilibrium. mg equals to h ha rho g. Rho vg, right? Yeah, rho vg. So ha is the volume. That means at equilibrium is this volume here of the water displaced. Okay? Okay. Then at displacement x, okay, when you displace it to x, then I will say that the upthrust is more, right? So then h, so it'll be, it'll be a times h plus x rho g minus mg equals to f. Agree? But actually a bit silly because this term here is the mg, right? And this is h plus x, right? So at the end of the day, it's basically x a rho g equals to f. Yeah, that's the answer. Why is that worth 3 marks?
Taking downwards is positive. Then it was F net equals to.
Oh, wait, I need to chuck in a negative somewhere. Sorry, I put a negative here. I put a negative there. I just throw in a negative. Why? Can one. I don't like play with negative one. All the JC teachers love to play with negative one. They like to show that they know how to show you where the negative is. For me, it's more like this. Oh yeah, how SHM, right? A equals to negative omega square x, right? If my x is pointing, then my a is pointing the other direction, right? Then just throw in one negative sign there. Lah. Why? Why? Do you know what my intention was? You don't know, right? You didn't realize that I just slapped on a negative sign, right? You still have to give me the mark though. Because I did according to what your answer key said, right? Like that, you bastard the teacher. Right? Teacher won't be able to tell, right? Shit lah, I want to take 1 mark, but I don't know whether or not. It's displaced downwards as x. Downwards is x. Downwards, I'm taking downwards as x. Positive x, right? So my resultant force is negative f up. Yeah lah. Damn stupid one I'm so tired of these kind of JC teachers trying to like prove that your negative signs must be very good. Yeah. My type of physics is engineering physics, not math physics. The JC teachers all like to do math physics. My one is engineering physics. You know what's engineering physics? Whatever works. Engineering physics. Right. If it's supposed to move, WD-40. If it's not supposed to move, masking tape. Anything else? Otherwise, I'm going to ask them to come in already. Okay? All right. Come in. Just sit down. They're on their way out. Yeah. Continue doing. You want to ask questions, you can ask. Okay, are you going to NLB to study? You came from home and going home? What, sorry? Oh, he fetched you here? Okay. Is there anything else you want to ask or like later or anything like that? Not at the moment, huh? Okay. You just ask me, okay? And then if I don't reply you by tonight, please let me know because today I'm damn shagged. So I'm afraid I fall asleep later when I get home. Can Wait, hey, this one. Wait, I went through with you, right? No, I went through with you. Did I send a recording, right? When do you remember when I see where? Oh, it was that day that she was not able to make it. Was it that day? Correct or hey, Amanda, please say just try to remember when I went through this with you. Huh? 13 March? No. No, I'm not talking about that one. I'm talking about recently only. Okay, recently I saw you but I didn't see her, right? That's because what, you're on your study break but she wasn't, is it? Yeah, what, you were on your study, you were... Come in. What? There was one day where I saw you and Cassandra but I didn't see her. Or was it the other way around? Huh? Hey, hello. Amanda, cannot be that blur, right? Oh my god. Or did I go through this with her and not you? Jialat. Long ago. No. I just recently went through it, what? Didn't I recently go through it? Wow, you're damn jialat. You're damn habis, you know, you. Wait, you cannot be so terrible. Wait. Or was it not you? Or maybe it's not you, you know? Maybe I went through with someone else. Then I blame you now. Correct or not? Wait, there was a truck. Then there was a truck on a slope. This was Cheshire, right? That day when I saw Cheshire. This was for Cheshire, right? Wait, Then we had trouble with this one, right? Okay, wait, then which one is it? Why am I folding my arms all the time? Yeah, let me just... not you! Not any of you! It was me! I sent it to you. Woo! This... Somehow this one is the... Oh my god, no leh. It's a bit different eh. So, this one, right, your question that you sent me, right? The B is a hollow. The one that Hui Jun sent me, right? The B is filled up with another material. So it's slightly different. You see whether you can understand first. Can you try Bye. Thank you, bye. Okay, Ken. Hang on, let's do a couple of things separately first, You wanted me to go through your paper 3, is it? Wait, I just take a quick look at it. I might not take that long because there's other people as well. Really? Okay. Hang on, let's see. Okay. Why? You're supposed to make sure that it's horizontal, is it? Okay, just listen. Every time you're supposed to make something horizontal, right? You measure the two ends, the height above the two ends. Okay? Let me just show it to you. Right. Don't ask me why this one cannot work or that one cannot work, but it's just a standard thing. If you want to make sure that a ruler is horizontal, you take a short ruler and you measure the height above the bench here and you measure the height above the bench there. The two heights must be the same. That's it. Okay, yes. Can, but what are you measuring? So what do you do here? You put the set square on top and you try to eyeball and see whether the set square is vertical, is it? That's the same as saying that why don't you just eyeball the ruler and say that it's vertical? How do you know that your set square is not at an angle? Okay, is this set square completely vertical? How do you know? Put another set square on top. Do you catch the instruction? How do you make sure that this string is horizontal? Measure the height. Yeah, measure the height of both ends of the string from the bench. Right? They must be the same height. If they're the same height, they are the. Are you not writing this down? What do you expect? What you expect to be able to absorb this in your head? Is it? I mean, another method could be that you can make sure that you can use a spirit level. It's just one of those tubes. It's one of those tubes that's like a bit like green with green fluid in it, and there's a bubble inside. All right, that's fine. Don't worry. Right? Huh? Like no, I would suggest you don't. Spirit levels are just for like if you're really damn lazy, then you just say this kind of things. Use a spirit level. Right. Yeah. So usually very lazy ones will say this. Yeah. Okay. Then they'll tell me things like, oh, it's not that I'm lazy, I'm efficient. Nah. Right? Ain't gonna work. Okay? Right? You always remember this, okay? Always remember this, guys. Alright? They will take everyone's answers and they will have a sample of answers. And then your answer will be pitched against those sample answers, which means that if those that they selected and they are good samples and your way you answer is shit, then you get shit marks. It's simple as that. You understand what I'm saying? Like there's no way in hell that the examiners will be like, oh, you know what? I feel bad for this guy. I think he understands. Let me give him more marks just because I feel bad today, right? Ain't no way. They look at the answer, they look at the sample answer, and they realize, yeah, this guy don't make any sense, right? Or this guy's just lazy, man. That's it. End of story. There's no need to argue anymore already, right? That's it. Not like, oh, I was hoping that you could understand.